Hello, ladies and gentlemen. Welcome back. We are on Unit 5.5. Today we're going to be looking at the square root family. All right, so the first thing we're going to do is we're going to do some solving of quadratic equations, and we're going to be using the square root to help solve them. All right, so let's do two of these before we move on to something else. All right, here we go. So we have 2x squared plus 8 equals 16. So we're going to go through the same process as solving any equation for x. So the first thing we're going to need to do is get rid of that plus 8. So we're going to go ahead and subtract 8 from both sides. So now 2x squared equals 8. Divide by 2. Okay, now we have x squared equals 4. And then remember, to get rid of a square, you take the square root. And when you do that, you need to put a positive and negative in front on the right side. So our final answer is x equals positive and negative 2. There are two answers. You're going, well, why are there two answers? Let me demonstrate with the calculator when I check it. See, if I take the 2 times, okay, I'm going to replace the x with the positive 2, right? So I'm going to put positive 2 squared, and then I'm going to add 8, and I get 16. Okay, now if I take the 2 times the negative 2 squared, and it's very important that you use parentheses, okay? You know that a negative squared ends up being a positive, right? So if I put that plus 8, I'm also going to get 16. So there are two answers. All right? Pretty straightforward. All right, let's go to the next one. Again, if I go too fast, please hit the pause button and then continue. All right, here we go. All right, so on this one, we are going to add 24 to both sides. And negative 57 plus 24, we're going to get negative 33. We're going to divide by negative 3. And we get x squared equals 11. Okay, we're going to square root both sides. And on this one, ladies and gentlemen, we're going to leave our answer as positive, negative square roots of 11. Because 11 is not a perfect square. See, if I take the square root of 11, I'm going to get a decimal. And I really don't want a decimal. I don't want that decimal. I would rather have you just leave it as the square root of 11. Now, like the last problem, it was a 4. 4 was a perfect square. There, we could simplify it. All right, but on this one, we're just going to leave it just like that. All right, let's keep going. Let's go to the next part. So in this situation, we have an object that is dropped from like up in the air. Its height in feet above the ground after t seconds can be modeled by this equation. Okay, maybe you've seen this equation in your science class, where the h sub o, that is the object's initial height in feet. So the graph of h equals negative 16t plus 200 represents the height of an object dropped from initial height of 200 feet. Okay, well, we're not going to graph this, but that's the equation. This is the initial height right here. So you'll notice that that went behind that plus sign, and that's the initial height. So the first question is, how long will it take the object to fall 100 feet? Okay, so that 100, ladies and gentlemen, that's going to go in for the h. So we're going to write 100 equals negative 16t squared plus the 200. So we want to know how many seconds does it take to fall to 100 feet. All right, so we're going to go through and we're going to subtract the 200. Okay, so now we have negative 100 equals negative 16t squared. We're going to divide by the negative 16. Okay, I'm going to need the help of the calculator here. So let's see, we've got negative 100, and we're going to divide it by negative 16. And we're going to get 6.25. Now it's okay, since we're dealing with time, it's okay to have decimals here. All right, so I'm going to rewrite this as 6.25 equals t squared. Now, just like before, we're going to go ahead and take the square root of both sides. And I'm going to put a positive and negative in front of that for the moment. Okay, but we'll talk about it here in a minute. So I'm going to go ahead and find the square root of that. So I'm going to go ahead and take the square root of 6.25, and I get 2.5. Okay, so positive, negative, 2.5. Now, this is seconds, right? All right. So the time is positive or negative 2.5. Well, it can't be both, okay? It can only be the positive, because you can't have negative time, ladies and gentlemen, right? Okay? If you could figure out how to go backwards in time, that would be pretty cool. But so we're going to take away the negative, okay? So it's the positive only. Okay, I'm going to get my pen back here. Okay, it's the positive answer only in this case, because time cannot be negative. So it takes 2.5 seconds for an object to fall 100 feet. That's like 1,000, 2, 1,000, 3, it's there. Okay, falls fairly quickly, right? All right, how long will it take to hit the ground? Well, when it hits the ground, folks, that's where the height will be 0 feet, right? Okay, so we're going to set 0 equal to negative 16t squared plus 200. Okay, subtract the 200. So I'm not going to show that. I'm subtracting 200 from both sides, folks. So negative 200 equals negative 16t squared. Okay, divide by the negative 16. And let's see, I need the calculator to help me out with that. So negative 200 divided by the negative 16, and we get 12.5. All right, so we've got 12.5 equals t squared. Square root both. Now again, we only need the positive here, okay, because we're not going to have negative time. So I'm going to take the square root of 12.5, square root of 12.5, and we find that it's approximately I'm going to round it to 3.54 seconds. So the time it takes, I'm going to put a wavy equal sign for approximately 3.54 seconds. All right, so 200 feet. Let's just hope it's not a rock or something like that. That would hurt if it hit you on the head. All right, moving on. Okay, so we're going to look at what do square roots look like on the calculator. All right, so we're going to use the graphing calculator to fill in the table. We're going to sketch the graph, and then we're going to answer the questions. So we're going to start off with the parent function. So on our calculator, we're going to go to our y equals, clear out anything that's in there, and we're going to put the square root of x. All right, now we're going to go to the table, and I'm going to fill in the table. So We're going to start with 0. Notice it goes 0, 1. Then I skip, well, then in 1, 1, because the square root of 0 is 1, folks. The square root of 1 is 1. Then notice I skip to 4, because 4 is a perfect square. The square root of 4 is 2. Square root of 9 is 3. Okay, and so on. Okay, you could probably fill that table in without the calculator. Okay, square root of 9 is 3, square root of, then the next one is 16, is 4, and so on. Okay, so let me fill this in. So we've got 0, 1, 2, 3, 4, 5, 6, okay? The square root of all those numbers, that's what you end up with. Now, what does the graph look like? Okay, ladies and gentlemen, so let's hit our graph button. Now, if it doesn't show up like that, hit zoom number 6. Okay, hit zoom 6 if it doesn't show up. Okay, so the graph looks like that. It starts right here at 0, 0. So we're just going to sketch this, folks. So we're going to put a dot right there, and I want you to mark it 0, 0, because that's going to be important later on. And it's just going to curve around like this and put an arrow on it. We're not going to sketch anything but the starting point, okay? And then put an arrow on the other end. Only one arrow. Only one arrow. All right, let's keep going. Let's do a couple more. Okay, on this one, we're going to put a negative in front of the x squared. So we're going to go to our calculator. And we're going to go to our y equals. And I'm just going to start over and put negative. Remember, the negative is under the 3. The square root of x. And first I'll go to the table, and I notice that in the table now, everything, when I take the square root and have that negative in front, everything now is a negative except the 0, 0. Okay, notice it's 1, negative 1. It's 4, negative 2, and so on. So this is going to be 0, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. All right, so before I answer this question, I'm going to go ahead and sketch this graph right here. So let's take a look at the graph. So on your calculator, let's hit the graph button. Oh, look at that. It's now curving down like that. Interesting. All right, so it still starts right here at 0, 0. Okay, please mark that. And then it curves down like this. Okay, so what does the negative do to the graph of the square root function? Well, it causes it to be a reflection over the x-axis. Okay, it flipped it upside down. And that's what I just said. This is a reflection over the x-axis. Okay, because if you go to the original one, there's the original one, and now this one is like that. All right, let's look at some more. I don't want to make this video too long. All right, now this one, you'll notice it has a +3 next to it. Now that +3 is not on the inside, so let's go to the calculator. Let's go to our y equals, clear that out. All right, the square root of x. Now, you have to hit the right arrow key to get out from underneath the square root. Again, hit that right arrow key to get out from under it. See how it disappeared? Okay, go back and watch it again if you didn't see it. +3. All right, I'm going to go to the table. All right, so now it says 0 is matched with 3, 4 is matched with 5. Okay, so 1 is matched with 4, and 4 is matched with 5. So this is 3, this is 4, this is 5. Okay, maybe you see the pattern here. And if I scroll down to the 9, there it is, it's a 6. Okay, well, it looks like we're starting with 3, 4, 5, 6. This will be 7, this will be 8, this will be 9. And if you don't believe me, go ahead and look at the table on your calculator. All right, So now if I hit graph, what in the world is it going to do? Whoa, whoa, it's way up here. Well, that looks like it's at 0, 3, folks. So what I'm going to do is I'm going to go 1, 2, 3. I'm going to put my dot here. Notice that right there. That's your starting point. 0, 3. And it's going to curve like that. So what does adding 3 to the outside of the function do to the graph of the square root function? Well, it moves it up 3. It moves it up 3 units. Remember, that's called a translation, a slide. It slid up 3 units. Okay, let's do another one. Now notice this one has the 7 is inside the square root. Interesting. All right, well, let's see here. So when I go here, I'm going to go the square root of x. Okay, but don't use the right arrow key. Now hit +7. See how it stayed inside the square root? Okay, now I'm going to go to the table and I'm going to see, oh, look at my table. That looks really weird. It starts at -7. So I'm going to go to -7. Notice I always skip the decimals. So let's see, -7. There it is. So -7 matches with 0. Huh. -6 goes with 1. -3 goes with 2. Gee, I bet it follows that pattern. 0, 1, 2, 3, 4, 5, 6. Let's see. So 0, 1, 2, 3, 4, 5, 6. And if you don't believe me, you could go ahead and scroll a little bit further on your calculator. Let's see. Yep, 2. Oh, I think I goofed here. Oh, I don't want the 0 in there. Look at that, ladies and gentlemen. It is a really good idea that I checked this, isn't it? All right, I need my eraser. Okay, I need my eraser. Here we go. I'm going to take out the 0. So the 0 has a decimal in it, so I think I goofed when I typed this. So we're going to ignore the 0, folks. So we're going to just put a line through there and put 3 here, 4 here, and 5 here. All right, let me double check, make sure that I'm okay now. So 2 matches with 3, and 9 matches with 4. Yep, I think I'm good. Okay, so what does the graph look like? Whoa, look at that. The graph started way over here on the left side. And it looks like that's 1, 2, 3, 4, 5, 6. That's left 7. Interesting. So that's our starting point, folks. 1, 2, 3, 4, 5, 6, 7. So mark that spot, 0. Whoops, not 0. -7, 0. And it goes like this. So what does adding 7 to the inside of the function do to the graph of the quadratic root function? Oh, it moved it left 7 units. Interesting. It moved it left 7 units. Not right 7 units, left 7 units. Okay? Well, think about this. What number would make x plus 7 equal 0? What number would make x plus 7 equal 0? That would have to be a -7. So that means it's moving. That's a horrible -7, isn't it? Let me fix that. That means it's moving left 7. Huh. Okay, keep that in mind. Something really important's going on there. All right, folks. I believe this is the last one. We're just gonna, yep, this is the last one. We're gonna do this one. So in this situation, we've got square root of x minus 3 plus 4. All right, so I'm gonna put that whole thing in. Now notice the -3 is inside the square root. Then the +4 is not. So I gotta be careful when I type this. All right, so here we go. Now notice I didn't make a table. That's okay. I don't really need a table because I have the calculator here. So we're going to go to the square root of x minus 3. Okay, now I need to get out from underneath the square root. I'm going to hit the right arrow key. Notice how the square root disappeared, and now I'm going to put a plus 4. Okay, now I'm going to go to the table real quick, and I'm going to look. Okay, I could make a table with this, couldn't I? Oh, notice there are error messages. That's a good sign. So let's see. Looks like it after the error messages, it looks like it starts at 3, 4. So you know what? I'm gonna go ahead and make a little table here. Anyway, even though I didn't put one on here, and I'm only going to do a few points. So it looks like the first dot is a 3, 4. And it looks like the next one is 4, 5. Okay, really, I don't need any more than that. So it looks like, ladies and gentlemen, this is my starting point, because that was the dot, the first one after the error messages that didn't have an error. All right, so 3, 4. Well, let me look at the graph really quick. Let me look at the graph. Oh yeah, look at where it starts. It looks like that's 1, 2, yep, that's 3 over, and 1, 2, 3, 4 up. Interesting. So 1, 2, 3 over, and 1, 2, 3, 4. So it looks like it's starting right here, which it is. That's 3, 4. And it goes like that. Okay, so ladies and gentlemen, what in the world is going on here? Well, it looks like it moved left. It moved, okay, where is it in relation to the parent? Well, no, it moved right. Sorry about that. It moved right 3 and up 4. Moved right 3 and up 4. Well, look, ladies and gentlemen, look at this and look at this. Oh, it's the opposite. Instead of moving left, there's a minus sign there. So what would make that equal 0? A positive 3. So it moved right 3 and up 4. All right, let's look one more. Okay. So this one's got a negative in front, x plus 6 minus 5. Okay, so let's see here. Let's do this really quick. So we got a negative, and then a square root, and then an x plus 5. Go get out of underneath the square root, and then minus 5. All right, I'm going to go to the table, and I'm going to go to, again, I'm going to go until I get to some error messages here. So let's see. Oh, there's some error messages right there. See the errors? Okay, now I'm going to scroll down and go, oh, look, there's the first one, negative 6, negative 5. That looks like that might be the starting point. So negative 6, negative 5. What was the next one underneath that? Negative 5, negative 6. Okay, but that first dot, that's our starting point, folks. That's our starting point. Okay, so it's pretty cool. It tells us where to start. All right, what does the graph look like? Oh, it's upside down. Oh, I know why. Because there's a negative in front. Okay, so I'm going to graph this. So it looks like it went left 6 and down 5. So that looks like that's where it's going to start. So left 6, 1, 2, 3, 4, 5, 6. Whoops, I don't want to put a dot there though. Left 6 and down 5, 1, 2, 3, 4, 5. So it looks like this is the starting point right here at negative 6, negative 5. But then it's curving down. Okay, so I just need to make sure it's curving down like this. Cool. All right, so that's what the graph looks like. So what did it do, ladies and gentlemen? Well, it's doing 3 things. It reflected over the x-axis. It reflected over x. What else did it do? It moved left 6 and down 5. And look, ladies and gentlemen, I could have figured that out just by looking at the equation. That's the whole point I'm trying to get you to see here. You should be able to now, I hope you've got the idea, just by looking at the equation without using a calculator, you should be able to tell me where it starts. Okay? So this one's started at positive 3, 4. This one started at negative 6, negative 5, and because of that negative, it reflects. So just really quick, if I do this, ladies and gentlemen, if I give you the square root of x plus 7 minus 3, where's the starting point? It's at negative 7, negative 3. It's the opposite of what's in the square root. So if I would draw this, negative 7, 1, 2, 3, 4, 5, 6, 7, and negative 3, it's going to start right here. That's your starting point. And then since there's no negative in front, that means it's going to curve like this without a calculator. Pretty cool. All right, we'll see you soon in class.